Hello, good morning. My name is Ishmael. Today we'll be looking at how to graph inequalities in a Cartesian plane. Now we have a question on the board that says we should represent x plus y less than 6 in a Cartesian plane. And mind you, this has to do with inequalities in two variables. You will have your x and y, okay? So let's see how we can present this on a Cartesian plane. Now the first thing you got to do is to get what we call the boundary line. The boundary line is simply change whatsoever inequality that is here to equal to sign. That gives us the boundary line, okay? So this is called the boundary line. And from this boundary line, we can now get the intercept of x and y, the x-intercept and the y-intercept. How do we do that? We say when x is 0. So if x is 0, what happens to this equation? We are going to have that y is equal to 6. This y equal to 6. This is our intercept on the y-axis. Next we do when y equal to 0. So if y is equal to 0, what will happen to x? X will also be what? Equal to 6. So this is called the intercept on the x-axis. Now we have gotten to intercept the x-axis and the y-axis. So let's go now to our Cartesian plane. So let me assume this box is my Cartesian plane. Okay. So this is going to be my y-axis. I make this my x-axis. This is my origin. So let's assume my 6 is here for my x. My 6 is here for my y. So we are going to connect this intercept of x and y now, okay? So let's connect the two intercepts. So x is 6, y is 6. Now, whenever you are presenting this on the Cartesian plane, we use a broken line to join these two. I'll tell you why I'm using a broken line to join these two points. Now we use a broken line because this is less than. That's to tell us that the set of values of solution to this will not include 6. So we always use broken line. So whenever you have less than or greater than, we use broken line, okay? And then whenever you have less than or equal to and greater than or equal to, if here was less than or equal to, it means that our set of solution will include 6, then we would have used a solid line, okay? So that is the case, but in this case we don't have less than or equal to or greater than or equal to, so that's why I join this with a straight line, okay? Now, having gotten this boundary line, this is our boundary line, this is our x plus y equal to 6. Now, having gotten this boundary line, the next thing is to determine the area that contains the set of solution, okay? Now, how do we do that? We'll come back to this inequality. Now, the best thing to use, or the best points to use, is the origin here. You know, at this origin, x is 0, y is 0. So we are going to test the validity of this, okay? So at this origin, if x is 0, y is 0, that will make this whole inequality here to become 0 is less than 6, okay? And 0 is less than 6 is a valid statement because truly 0 is less than 6. So this statement is valid. Now, whenever the statement is valid, this region, remember this boundary line divides this entire plane into two regions, this region below and this region above. So the region that contains this origin will always be for the valid statement. Whenever the inequality is valid, the region that contains this origin here is the acceptable region. So that is the region that contains the set of solution to this. While this other region is not acceptable, we are going to shade them off. So this unshaded area is our set of solution. I hope you gain value. Thanks for watching.